All right, in this video, we want to look at solving systems of three variables. So it's basically a combination of two of the methods that we looked at when we were solving a system of two equations. So we're going to combine the elimination method and the substitution method all in one. Now, it's not that the math is difficult, it's just that it's a long process. So there's a lot of little spaces to kind of mess up a sign or accidentally, say 2 plus 3 is 6. Instead, you accidentally multiply instead of adding. So there's a lot of little spaces for little mistakes. So you just want to go step by step and make sure that you are checking each step as you go through. Okay. So when we go to solve a system of three variables, we're going to start off with the elimination method. Okay. After we've done our elimination method, then we're going to solve it with substitution or elimination, up to you. And then finally, we're going to use substitution to go back and plug in. Okay. So I'm going to talk through this first one so you can kind of get the idea of what's happening, because the steps seem kind of confusing until you actually see it at work. Okay, so the first step actually says we're going to start with elimination. We're going to pick a variable to eliminate, and we're going to eliminate that variable using two different combinations of two equations. So that seems kind of crazy. Let's look at what's happening. So I'm going to look at my equations and I'm going to decide which variable I want to get rid of. At this point, there's a lot of different routes that you could go. So I try to pick one that has a variable by itself and maybe there's positives and negatives. So in this example, I'm going to go ahead and I'm going to pick y. And I'm going to pick y because if I combine the first and the second equation, equations 1 and 2, so looking at just those two equations, I have a 4 and a negative y, which means if I multiply the bottom equation by 4, then I'd have a positive 4 and a negative 4. So those would cancel, okay? So let's do that. Okay. Remember, I'm going to do this in two different scenarios here. So we're going to look at them one by one. Okay. So again, I've picked y, and I'm using equations 1 and 2. I'm going to need to multiply that bottom equation by a 4 to be able to actually cancel something. So I'm going to go ahead and write my equations out. X plus 4y minus 3z equals negative 8. We did nothing to the top equation. However, to the second equation, I'm going to distribute that 4. So I'm going to get 12x minus 4y plus 12z equals 48. Okay. Now, just like elimination method we did before, I can now add those two equations together. I'm going to end up with 13x. The y's will cancel, which is what we wanted. Remember, we picked y to cancel. Plus 9z equals 40. Okay. So I'm going to have to leave that one alone for a minute. And now I'm going to need my other combination. Remember, it says I'm going to pick two different combinations of two equations. So I've already picked equation 1 and 2. Now I'm going to pick equation. I still have to use that y, right? I still have to eliminate y. But this time I'm going to eliminate it from equations 2 and 3. Okay. So I'm going to write those equations down. Now, this one is real nice, because if I look at y, they've already got the same number with opposite signs. So I don't have to multiply anything. I can just straight up add these two together and I'm going to get my y to cancel. So it's going to be real nice. Okay. So I'm going to put with 4x, my y's cancel. 9z equals 13. All right. So now what I'm going to do, this is now an equation like what we just did in chapter 5 point, it's not 5.1, in chapter 8.1. Oh, I have a little typo up there. That's why. Chapter 8.1, sorry. Okay, so I'm going to put these two together that I just solved for. So now what I have is 13x plus 9z equals 40. 4x plus 9z equals 13. So I've got a system of two equations with two variables. This is just like what we did in the last section. I'm going to solve these. I have the choice of either substitution or elimination. Now, I kind of want to do elimination here because I've already got a 9z and a 9z. All I need to do is make one of them negative and I'll be able to eliminate. So I'm going to go ahead and, doesn't matter which one, I'm going to multiply the top one by -1. So that now when I add them together, my z's are going to cancel. So I have -9x, z's cancel, equals -27. I'm going to keep solving this. I'm going to divide by my -9. And x is going to equal 3. So now I have one of my variables. Perfect. This is where no choice anymore. I'm not going to eliminate. I'm going to go back, substitute, and substitute. So I'm going to go back to my two equations that had two variables. I don't care which one of those, but I'm going to substitute in a 3 to one of those equations. So again, I like smaller numbers, so I'm going to come back up here. So I'm going to have 4 times that 3 that I just found equals 9z, or plus 9z equals 13. So I'm going to solve this for z. So here we go. 12 plus 9z equals 13. Minus that 12. 9z equals 1. Z equals 1/9. So now I've got 2 out of my 3 variables. So I'm going to take both of these back to one of my original equations. Let's see. I'm going to go ahead and pick the third equation, just because my numbers are a little bit smaller there. So I'm going to take both of these back, my x and my z. I'm going to take it back to that third equation. So I'm going to have x plus y plus 6z equals 1. I'm going to plug in my z and my x, and I'm going to solve for y. So I've got 3 plus y plus 6 times 1/9 equals 1. So I have 3 plus y plus 6 over 9 is 2/3. I'm going to combine those like terms. So I'm going to have y plus 11/3 equals 1. And then I'm going to subtract. So y is going to equal -8/3. So now I have my x, my y, and my z. I'm going to write my answer alphabetically here. So I put my x, my y, and my z. All right? So that's all of the steps to how we were going to solve a system by elimination and substitution together in one so we can solve for those three variables. Okay? All right, let's look at another example, putting all the steps together just so we can kind of follow it, make sure we know what's happening. All right, so first thing I'm going to do is I'm going to need to pick a variable. Now I'm looking at the numbers 3, 7, 2. Not many things in common there. 2, 3, and 3. Okay, that one's looking good. The 3's are the same, but no positives and negatives. They're all just negative. So now if I look at the z, I have a -2, a +2, and a +4. Okay, 2 and 2 are the same, so that's good. And I have positive and negative. I'm going to go ahead and I'm going to pick z. Okay. And I'm going to go ahead and pick my equations 1 and 2. Okay. And I'm just going to go ahead and pick them over here too. I'm going to pick equations 1 and 3. So I've got my two equations that I'm going to solve, my two different combinations. So let's start off with the first one, equations 1 and equations 2. So I've got 3x minus 2y minus 2z equals 6. And then I've got 7x minus 3y plus 2z equals -1. Okay. Now remember I picked z, so I want to eliminate z here. So I notice, oh, I've got a +2z, -2z. It is already ready to go ahead and add those two equations together. So I'm going to get 10x minus 5y. My z's are gone, and that's going to equal 5. Okay, so I'm looking good so far. Let's look at my next combination. I've got equation 1, so I'm going to write that one down. 3x minus 2y minus 2z equals 6. And equation 3, I've got 2x minus 3y plus 4z equals 0. All right, so when I look at this, I say, okay, well, I need the z's to cancel because that's what I've picked here. To do that, I'm going to need to multiply the top equation by a 2. All right, because that's going to give me a +4 and a -4 for my z's. So I'm going to go ahead and distribute this here. So I'm going to have 6x minus 4y minus 4z equals 12. All right, now that I've got my variables to be the same number but opposite signs, I'm going to go ahead and add those together. So I'm going to get 12x. Oh, sorry. I'm going to get 8x. See, that's what I meant by there's a lot of places just make silly mistakes. Sorry about that. So I'm going to get 8x minus 7y. My z's cancel. Equals 12. All right, so now I've got my two equations. I'm going to go ahead and use these two line them up here. I've got 10x minus 5y equals 5. I've got 8x minus 7y equals 12. Okay, so elimination, I don't know, it's kind of big numbers. How about I do one where I do substitution so you can kind of see both ones. So, you know what, I think I'm going to go ahead and solve. I'm going to do substitution. So I'm going to solve for my y here. Okay, so I'm going to say 10x minus 5y equals 5. Move that 10x over. Negative 5y, negative 10x plus 5. Divide by negative 5. So y equals 2x minus 1. Remember in substitution, once I've solved for a variable, I'm going to take that back to my unsolved equation. So I have 8x minus 7y equals 12. Remember, I say the letter, but I'm actually going to plug in 2x minus 1. So now I'm going to do my math on this. I'm going to go ahead and distribute 8x minus 14x plus 7 equals 12. I'm going to combine my like terms. Negative 6x plus 12 or 7 equals 12. Move that 7 over. Divide. Okay, so I've got my first variable solved. Substitution says that once I've got that solved, I'm going to go back to where I was solved for my y. So I have y equals 2 times that negative 5/6 minus 1. So I'm still doing my substitution here. So I've got y equals negative 10 over 6 minus 1. I could reduce that, but I'm just going to go ahead and do it all together while I'm solving here. So I'm going to end up with, let's see, negative 16 over 6, which is going to reduce to a negative 8 over 3. So now I've got an x and a y that I can take back to any of my 3 equations in the very beginning. Okay, so I'm going to take both of these back up to one of these 3 up here. Doesn't matter which one that you pick. Again, I like smaller numbers. So I'm either going to go for equation 1 or equation 3. I'm just going to go ahead and pick this first equation. So let's write it down. 3x minus 2y minus 2z equals 6. I'm going to plug in my x and my y that I got. So I'm going to have 3 times negative 5 over 6 minus 2 times negative 8 over 3 minus 2z equals 6. So I'm going to go ahead and solve this. Negative 15 over 6. And I'll go back and I'll reduce all this here in a minute. Plus 16 over 3 minus 2z equals 6. I'm going to go ahead and combine these like terms here. Well, I know that 15 over 6 can already reduce to be 5 over 3. So I've got a negative 5 over 3 and a positive 16 over 3. And probably you're just doing all this in the calculator anyways. But I'm doing these step by step for you here. So I'm going to now move that 11/3 over. So we get 7/3. Divide by negative 2. So z is going to equal negative 7 over 6. So I've got my 3 variables. Remember, we're going alphabetical, so I'll put my x, my y, and my z. So that's how we're going to solve a system of 3 variables. I'm going to do a combination of elimination and substitution. I will solve. Once I finish solving, I will put them in alphabetical order, my x, y, z, similar to an ordered pair.